In here, we will be looking at different window operations in pandas, and we'll compare them to SQL. So we'll go ahead, we'll repopulate our database tables with the same data set we've seen so far, and we'll just perform some generic rolling operations. Here I have a rolling operation that occurs on just the number of rows. So we'll perform a rolling window on every 2 rows. And then what pandas loves to do is that it works with time series data really well. And that is because pandas comes from the financial sector and they love time series data there. So in this first rolling, you can see every 2 rows, I have a window just kind of sliding down here. And in this example, I'm actually rolling on the date column. I'm binning by every 12 hours. Remember, our data is 6 hours apart each epoch. So this is almost the same thing as every 2 rows, right? Lastly, pandas has an extremely flexible endpoint on these windows. Do you want to, for each window, do you want to include the rightmost point? Do you want to include the leftmost point? Do you want to include both or neither? I think that functionality will be quite hard to replicate in SQL. But James, can you perform these types of rolling window operations?
We have to look at the data because there might be a shortcut or a cheat that we have in this data. Here's the thing. We keep coming back to the same point about SQL, which is it really is kind of defining what the size of the output query is as part of the underlying syntax, as opposed to you directing that via the syntax here. Here, you want to do a rolling on every day. So you want to group every day together and you want to group every day together and perform. No, you want overlapping, right? So you want everything that's within a day. So everything within 24 hours is taken into the signal. So those rows at the bottom, 3 and 4, are within 24 hours of each other. So to be considered part of the signal. Well, what that means is, and when you deal with the rolling in pandas where it's a time series, the window size might be fixed, in the sense that it's like a fixed amount of time. It's a fixed amount of seconds. And pandas will complain to you if you try and do this rolling on something that's not fixed. Like, I suspect you can't do it by month because sometimes it's 31 days and sometimes it's 28 days.
Yeah,
so I suspect
I think it might make some inferences based on, right, if it's saying February, it knows, or depending on the year too. So you probably need full date time, date types to have pandas intelligently figure that out. I assume with all the work that they've put into those date time types, they probably work, but that's a very good point to bring up.
However, the thing with SQL is we're thinking about the output size and we're also thinking about the input size. Our window function cannot operate on a window that doesn't have a fixed predetermined size. In the previous cases, you can see it can operate on these kind of expanding windows, and that's what like the cumulative sum is. It can operate with a frame function in terms of some rows and some rows preceding. But here, we want something that doesn't have I should be very careful, either an expanding size or a fixed known size ahead of time. A size that is known independent of the data is what I should say. And here, we do not know the size of the window independent of the data. We don't know if we have a bunch of signals in one day and then a big gap or not. With the window function, we can say, okay, do the expanding, because we don't need to know what's in the data to do the expanding. We can say, do it on every row and the immediately 3 preceding rows. We don't need to know what the data looks like, but we cannot do this with the window function. So what we'll need to do.
I was going to say, what you're saying is essentially that SQL can perform these window functions based on the number of rows because the size of the number of data points in your window stays the same. But as soon as it has to become aware of its data in order to calculate that window size, we're pretty much out of luck.
With the window function. However, there are alternate approaches that you can take. And the alternate approach that you'll typically take is you're going to make SQL aware of this data, and you're going to do that by bringing the data into the single tuple and then filtering. And so for this date time window problem, what I would do is I would bring into my data set every signal and every other signal. And then I'd create a synthetic column which I could group on, which would be whether those signals were within 24 hours of each other. I'd group on that, and I'd perform my operation. So what this is going to look like is as follows. I'm going to select from the data, and I'm going to select from it twice. I'm going to do an inner join, data, as D1, and I'm going to get every signal against every other signal. And you can think, for now, I'm just going to do it like this, Cartesian product of every signal against every other signal. Now, even though I conceptualize this as the Cartesian product, the actual underlying implementation may not be a Cartesian product at all, because the SQL engine is very smart, and it knows how to do things a little bit more efficiently. Here, in this case, because I return the Cartesian product of the rows, of course, it's going to be the Cartesian product. But in general, that's not the formulation for this. Now that I have this, I can look at 2 timestamps. So I can compare every timestamp against every other timestamp. You'd never do this in pandas. This is a quadratic operation. But in SQL, you declare it, and then the SQL engine figures out what you want. And in many cases, this may not be quadratic. So what I'll do is I'll turn this into an inner join. And I'll do this on the windowing where my D0 date, I'll do this. I'll make sure that we have an ordering of these. So I'll make sure my D0 date and my D1 date are ordered in this fashion. So here we go. So we have each one of these, and I'll select D0.star. I'll show you a little trick that I like to do when I do this, just so I can see which is which. This is D0, and here's D1, so I can see which came from which table. So there we go. And there's a lot of data, so I should have probably should have put a limit on that. These data sets are a little bit big. Okay, let's see if we can put a limit on that and see this working. Okay, so you can see that's all the data I have. Now, what I'm going to do is I'm going to find not only this in an order fashion where D0 comes first, but also, I'll express it like this, but also any case where this date minus this date is less than or equal to 24 hours. And here, actually express it like this. There we go. And I'm going to put an and here. There we go. So now I have every row where, or every combination of rows where these 2 sides are within 24 hours of each other. And so I've constructed all of the data that I want. Now that I do this, I need to figure out what the grouping parameter will be to partition this down into non-overlapping groups. But that's actually not too tricky, because that's just going to be a computation on one of these 2 dates. And because I am looking backwards, I think it's going to be a computation on D1. So what I'll do is I'll do a date trunc, the day from D1. You want every 24 hours. So this is going to be a little ugly. What I want to do is I want to figure out which 24-hour window we're in. Yeah. And I want to group this by what 24-hour window we're in. And so what you can see, by the way, is in this output on the left-hand side, these are all the signals, and these are all the windows they belong to. So I think I could just group this uniquely on D1, because each one of those corresponds to the window you're in. So I think I could just do this, group by D1.date. And then now I'm going to get D1.date, and I'm going to get D0's values, and I'll do let's do a mean on these. So here is the mean per 24 hours. So let's see, does that make sense? And then let's do an order by D1.date. And here you can see I have every signal that I had and the mean of all the values that were 24 hours within that. Where this becomes really tricky is, notice, after 6 o'clock, I don't have anything else. Or if I have gaps in this date, what do I do? Well, if I had gaps in this date and I needed to produce, something where the window goes dry and then the window is no longer like that, in pandas, I think you would probably do that with actually, I have to think. If you have big gaps, like if you have a 3-day gap and you're doing the rolling, it will not create nan rows. It'll just give you what you have, right?
I think it might give you nan rows because it asks for a minimum number of periods, and
but it's not going
to skip it and not include that in the output unless you
Yeah.
reindex it first and introduce the nans manually.
or if you resample it. So this is actually
Yeah.
close enough to what you have. But what you really wanted was you actually wanted like each day. No, this is what you wanted. This is what you wanted.
Yeah.
Because what I think you'd want in the pandas situation is you want to first resample it to force it to have every time signal that you are anticipating getting, and then do that. And SQL doesn't have a resample. So what you're going to have to do is you're going to first have to construct what the output looks like, and then generate this. You do something not too dissimilar in pandas. Have you ever constructed a synthetic date range in pandas, re-indexed on that synthetic date range to force the nans, and then performed a grouped operation so you get the nans where there's missing data?
Yeah.
In SQL, you do something
evenly binned or evenly frequency data, right? You're not dealing with gaps you might not be aware of.
You do very similar in SQL, but instead of resampling or re-indexing, what you do is you'd first construct the date range with the generate series, and then you join against it. But with that said, I think I managed to solve this problem. Let's see what we have next.
So next up, we actually had another expanding window operation. However, since you've broken down our cumulative sum question, I think we already know that you can do an expanding window operation in pandas. So instead, can you nest a window function within a group by? In pandas, it's an easy group by and then rolling. And for each of these groups and each of these facets, you get a nice little rolling window. And SQL, I'm pretty sure you can do this.
This is very easy. Because here we know what the output's going to be. It's going to be like a transform type output. We're going to have the same number of rows. Because we know what the output is going to be, we know what the approach is going to be. The approach is going to be some sort of window function. Here you want a sum of, say, some value over some partition. And we're going to partition by, say, the facet, ordered by, say, the ID. Whereas pandas has a natural ordering because it's an in-memory data structure. It's a columnar structure. Here, SQL doesn't have a natural ordering, so I'll just use the ID column, which was your index column. And the last piece that you need to get that fixed window size is you're going to say rows, and I can never spell this right, rows 3 preceding to current row. We can set the up to current row. I have to remember how to write that. Between. This is, come on. They're trying to make this. It's like between, I think it's between this and current. Rows between 3 preceding and current row. There we go.
Oh, man.
Yeah. You do it enough, you kind of remember. It's the same thing with pandas. I can never remember any of the arguments. I got to open up the docs on the side. But once you get the mindset, looking it up is fast.
Yeah. And it's all about the transformations here.
Yeah.